So here we have section 6.3, test for parallelograms. So here's our main ideas. Recognize conditions that ensure a quadrilateral is a parallelogram, and then prove points are a parallelogram. So no new vocab this time. All right, so these things are similar to the ones from the previous section. Oh, these should all say 6.3 at the top. My apologies. That's confusing. Anyway, so these are if-thens, but in reverse. So if both pairs, so if you remember before in 6.2, these are 6.3, we had rules that say if it's a parallelogram, these things are true. This is the reverse. If these things are true, then it's a parallelogram. So opposite sides congruent, opposite pairs of angles are congruent, the diagonals bisect each other, and then if one pair of opposite sides is both parallel and congruent, then it's a parallelogram. So that one we haven't actually seen before. So here, example 1, determine whether the quadrilateral is a parallelogram, justify your answer. So this would be yes, both pairs of opposite angles are congruent. So that and that are equal, that and that are equal. So that's actually this one right here, 610. So example 2 here, find x and y so that this is a parallelogram. So using sides, the sides have to be equal to each other, which means I need to solve two sets of equations. So for x, 6x minus 12 has to equal 2x plus 36. And for y, 4y has to equal 6y minus 42. So for the x's, bring this guy across, it gives me 4x minus 12 equals 36. Bring the 12 over, 4x equals 48, divided by 4, x is 12. For the y's, bring this guy over, negative 2y equals negative 42, divide by negative 2 gives me 21. So 3 here, x and y, so the quadrilateral is a parallelogram. So similar thing, opposite corners have to be equal. So for x, that is 7x is equal to 56. There, it has to equal that. And for y's, 4y plus 4 has to equal 5y minus 26. So this one's just divide by 7. So x is 8. This one, bring so that's negative 1y plus 4 equals negative 26. Negative 1y equals, so subtract the 4 across, negative 30, divide by negative 1, so y is positive 30. And our last example, determine whether those corners make a parallelogram. Use the slope formula. So if opposite sides are parallel, that shapes a parallelogram. So we need to find the slope from A to D, from A to B, from D to so on and so forth. So give myself a little bit extra room here. So we can use these points. So the slope between A and B is equal to y2 minus y1 over x2 minus x1. So that's negative 1 over 5. So then we'll do, so AB has to be parallel to DC, so we'll do DC next. So between D and C, that's going to be y minus y over x minus x. Right? Oh no, I flipped that. That one's backwards. Sorry. No. Y minus y, x minus x. Oh, I did that one backwards. I did that. So, no. y2 minus y1, x2 minus x1. So now you're seeing what happens if you lose track of where you are. 2 minus 3, 8 minus 3, right? So down here, for DC, y minus y, that one's backwards, that's why, x minus x, negative 1 over 5. So those are parallel. And they have to do the same thing for AD and for BC. So for AD, we'll do 3 minus, nope, that's the x's on top. I'm not doing this problem very well at all. So AD is going to be y minus y over x minus x. So that's 3 halves. For BC, y minus y over x minus x. So these two are parallel. Remember, parallel lines have the same slope. these two are parallel. Parallel lines have the same slope. You can also, I did that the long way just now. The shortcut would be, remember, you can just count with this. So this from A to B is over 1, 2, 3, 4, 5 down 1. So DC needs to be over 1, 2, 3, 4, 5 down 1. So they're parallel. Same thing for D to A, over 1, 2, up 1, 2, 3. Over here, over 1, 2, up 1, 2, 3. So they are parallel to each other. That's the end of this section, mislabeled as it is.